Hello friends, let's start with Unit 12, range, quartile deviation, mean deviation and standard deviation. They all are the methods of absolute measure of dispersion. As we know that the absolute measure of dispersion or a variation is those measures of variation or dispersion which are expressed in the same statistical unit which the original data are given, such as rupees, kilogram, tons, pounds, etc. So we will study one by one method. First is the range. Range is the difference between the maximum and the minimum observations in the data set. Is the range for the data set. That is, range is equal to L minus S, largest value of item, and smallest value of item. For example, find the range of the data 21, 6, 17, 18, 12, 8, 4, 13. So this is the individual observation. Here the highest value is 21 and the lowest value is 4. We apply the formula range is equal to the highest value minus lowest value, which gives the value of 70. So this is the example of the individual series for finding the range. Next is the continuous series. Calculate the range for the given frequency distribution. Class interval is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 till 70 to 80. Frequency is 2, 3, 14, 8, 3, 8, 2. So first of all we will find the range, that is the upper class boundary of the highest interval. In case of the group data, we can say that continuous series minus lower class boundary of the lowest interval. So upper class boundary of the highest interval is 80 and the lower class boundary of the lowest interval is 10. So the range is maximum minus minimum, that is 80 minus 10 is equal to 70. Next is the quartile deviation. The half distance between the 75th percentile, that is third quartile, and 25th percentile, that is the first quartile, is called the quartile deviation or semi-interquartile range. Next is the formula for quartile deviation. Formula for quartile deviation for ungrouped distribution is Q3 minus Q1 upon 2, where Q1 is the lower quartile and Q3 is the upper quartile. This is the formula for ungrouped data. Q1 is the n plus 1 by 4th item, where n is the number of observations. Q2 is the n plus 1 by 2th item. Q3 is the 3 into n plus 1 by 4th item. Here n is the total number of observation. It is important to note that you need to arrange the given data values in ascending order before estimating the quartiles. Now quartile deviation for group data is L1 plus Rn upon 4 minus E upon F into L2 minus L1. QR is the rth quartile, L1 is the lower limit of the quartile class, L2 is the upper limit of the quartile class, F is the frequency of the quartile class, C is the cumulative frequency of the class preceding the class quartile class, N is the number of observation in the given data set. First example is find the quartiles and quartile deviation of the following data. So we need to find out first quartiles and then quartile deviation. First of all, we need to arrange the data in ascending order. It is must in quartiles. So the data in 2, 5, 7, 7, 8, 8, 10, 10, 14, 15, 17, 18, 24, 27, 28, 48 in ascending order. Here the total number of data observations are 16. Q2 is the median of the given data set because n is the even. So formula is n by 2th observation and n by 2 plus 1th observation divide by half. Half into 8th observation plus 9th observation, that is 10 plus 14 divide by 2, which gives the value of 24 by 2, that is 12. So Q2 is equal to 12. Now, median of the lower half of the data. Same formula will be applied over here. Half into 4th observation plus 5th observation, because number of observations are even. The total observations are 3, 3, 6, 7, 8. Divide by 2 4th and divide by 2 plus 1th 5th observation. So here in the series 4th observation is 7th and 5th observation is 8. Their sum is 15, which is divided by 2, 7.5. Also the upper half of the data, again it is the even number of observation. Q3 is the median of upper half of the data. Half into 4th observation plus 5th observation. In the series, 4th observation is 18 and 5th observation is 24 divided by 2. It gives a value of 42 by 2, 21. That is, now we will find the quartile deviation. The formula is quartile deviation is upper quartile minus lower quartile divided by 2. We have already found upper quartile 21 and the lower quartile 7.5 divided by 2. That is a 6.75. Therefore, the quartile deviation for the given data set is 6.75. Next example is calculate the quartile deviation for the following distribution. Class interval is given 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Frequency is 5, 3, 4, 3, 3, 4, 7, 9, 7, 8. First of all, we will arrange the data in ascending order, but it is already in ascending order, so there is no need to change it. Here we need to find the quartile deviation. So first we will calculate the cumulative frequency for the given data. So this is the table: class, frequency and cumulative frequency. Cumulative frequency, how to find the cumulative frequency? You just see, first remains the same, another would be cumulatively added. That is 5 plus 3, 8, 8 plus 4, 12, 12 plus 3, 15, 15 plus 3, 18, 18 plus 4, 22, next is 22 plus 7, 29, 29 plus 9, 38, 38 plus 7, 45, 45 plus 8, 53. Next is, it is ungrouped data, it is a group data, so number of n is the sum of frequency over here, is equal to 53. So we know that QR is equal to L1 plus Rn by 4 minus C upon F into H, or we can say that L2 minus L1. Here R is equal to 1, N by 4 is 53 by 4, because Q1 1 lower quartile, so we take R is equal to 1. n is the sum of frequency divided by 4, that is 13.25. Q1 lies in the interval 30 to 40. In this case, quartile class is 30 to 40. So lower limit is 30 and upper limit is 40. The frequency of the quartile class, here we need to point to be noted. We need to take the frequency of the quartile class, that is 3, and C is the cumulative frequency of the class preceding the quartile class, which is 12. Now, by substituting all these in this formula and with the help of calculator, we will get the answer 34.167. In a similar way, we can find Q3, that is R is equal to 3. So we need to find out 3n by 4. Again, n is the sum of frequency over here. So we need to look at the cumulative frequency column. Q3 lies in the interval 80 to 90. In this case, quartile class 80 to 90. Lower limit of the quartile class is 80. L2 is 90. Frequency is 7. C is the cumulative frequency of the class preceding the quartile class is 38. Again, all these values put it in the formula, and with the help of calculator, we will get 82.5. That is the Q3. Finally, the quartile deviation is Q3 minus Q1 upon 2, which we have already found. Put it in the formula, and we will get quartile deviation is 24.1665. Hence, the quartile deviation of the given distribution is 24.167. Next is the mean deviation. Mean deviation is the arithmetic mean of the absolute deviation of the observations from a measure of central tendency. The formula of individual observation of mean deviation is about, if we are finding about mean, then is summation of x minus x bar. X bar is the mean upon number of the observation, where d means deviation, x minus x mean, and n is the number of observation. Mean deviation about mean is summation of x minus median upon n. Summation of d again upon n, where d is the x minus median and n is the number of observation. Now, in case of discrete series, the formula remains the same, but only the thing is that we will multiply it in the numerator by frequency, because in discrete series there is a frequency table also. So, summation of f into d upon n again, where n is the sum of frequencies or total of frequency. Mean deviation about median, if we are finding, then summation of f into x minus median upon sum of frequency. So, this is the major difference between individual and discrete series is, in denominator in individual series there is a number of observation, and in discrete series there is a sum of frequency, and in numerator we will multiply it by frequency. In case of continuous series, the formula would be different. The calculation of mean deviation is, mean deviation about mean is summation of frequency, that is mode of m minus x mean. M is the mid value, and if we are finding mean deviation about mean is summation of f into d upon n, where again n is the sum of frequency and d is the m minus x mean, where again m is the mid value and x mean we already know that. So these all are the formulas of individual series, discrete series and continuous series for the calculation of mean deviation. And remember one thing, we need to ignoring the negative sign in mean deviation, because we have put over here absolute sign. Now first example is find the mean deviation about the median for the following data. This is the individual series. We already know that arrange the data first in ascending order in median. The total number of data values is 9. 9 is odd, so the formula for median is n plus 1 by 2th observation, that is 9 plus 1 divided by 2 fifth observation. Median is equal to 10. Fifth observation, we look at the series, so it is on the position, that is 10 value. The value is 10. Now we need to find out all the absolute values of the respective deviations from the median. From the median is 7, 6, 5, 4, 0, 1, 2, 5, 6. Now we will apply the mean deviation. We know that summation of x minus median upon n, where n is the number of observation. So this is the value is 4. So this is the procedure for finding the mean deviation of the individual series. Next is calculate the mean deviation about the mean for the following frequency distribution. It is a continuous series first of all. First is the classes, second is the frequency. So first of all we need to find the mean, that is first classes, frequency. Sum of frequency is 25. Then we need to find out the mid values. Mid value we know that lower limit plus upper limit divided by 2. The lower limit is 0 and upper limit is 4. 0 plus 4 divided by 2 is 2. Next is frequency into mid value. First of all, we will find out the mean, that is summation of fi xi upon summation of f. After that, we will subtract it from the mid value. So we need to find out first mean. Then we need to make it the table mode of xi minus x mean. Next is frequency into xi minus x mean, because it is a continuous series. So the answer is 96, that is summation of fi xi minus x mean is 96. Mean is 9.2. Mean deviation is summation of f xi minus x mean upon n, where the summation of f is, numerator is 96 and denominator is summation of frequency, that is 25, which gives the answer 3.84. Next is the standard deviation. The standard deviation is the positive square root of the arithmetic mean of the squares of the deviation of the given values from the arithmetic mean. It is denoted by Greek letter sigma. It is also referred to as the root mean square deviation. The square of the standard deviation is a variance. So it is also a measure of dispersion. First of all, again, the formula for the calculation of standard deviation for ungrouped data is, or individual series, is sigma is equal to under root summation x minus x mean upon number of observation and numerator, the square of the numerator, or we can use sigma is equal to summation of xi square upon n minus summation of xi upon n whole square. Formula for discrete frequency distribution is, calculate of standard deviation for discrete frequency distribution is by assumed mean method. That is, let x be their mean and a be the assumed mean. D is the deviation, x minus assumed mean. Standard deviation is equal to under root of sigma fd square upon capital N minus sigma fd upon n whole square. Then for continuous frequency distribution is under root summation of f x minus x mean whole square upon capital N, where capital N is the sum of the frequency. There is another shortcut method or step deviation method where d is equal to x minus assumed mean upon c, where c is the width of the class interval, and standard deviation is equal to c into under root sigma fd square upon n, where n is the sum of frequency, minus sigma fd upon n whole square. The first example is the number of television sold in each day of a week are 13, 8, 4, 9, 7, 12, 10. Find its standard deviation. First of all, we will recognize it whether it is a continuous series, discrete series or individual series. So it is an individual series, so we need to apply formula of individual series. There are x observations, x square in second column. Find the sum of the x observation and find the sum of the x square. Then it is individual observation, so we will apply the formula of individual observation or standard deviation, that is sigma is equal to under root sigma x square upon n minus sigma x upon n whole square. With the help of calculator, you can do all the calculations, which gives the answer under root 8. And standard deviation is equal to 2.8. Next example is the marks scored by the students in a slip test are given below. One is the observation 4, 6, 8, 10, 12. Another is the frequency 7, 3, 5, 9, 5. Find the standard deviation of the marks. It is a discrete series because the frequency is given. So here we will apply the formula of the discrete series. This is the first observation x, second is the frequency, d is the deviation, that is x minus a assumed mean, f into d and then fd square. We will make all these columns. According to the formula, we need sum of frequency, that is n, we need sum of fd, that is 4, we need fd square, that is 240. Put all the figures in this formula, that is standard deviation is equal to, with the help of calculator we do all the calculations and we get the answer, standard deviation is equal to 2.87. Another example is find the standard deviation of the following series. Marks and number of students are given. So it is a continuous series, so we need to apply continuous formula for standard deviation. Let the assumed mean A is equal to 35 and C is equal to 10. Assumed mean we will assume from mid value. And mid value how we will find? Lower limit plus upper limit divided by 2. So this is the marks, this is the mid value and this is the frequency. Then D, x minus a, and D is equal to x minus a upon C. C is the class size. According to the formula we need to find FD, and then FD square. First of all, we will make this table and all these values we need to find out, and then take the summation of F, FD and FD square. Now, applying on the formula of standard deviation for continuous series, that is standard deviation is equal to C into under root sigma FD square upon n minus sigma FD upon n whole square. As we have already calculated all these values in the table, so we need to put it over there, and then we will find standard deviation with the help of calculator. Again, apply Baud mass while doing the calculation. Remember this thing, apply Baud mass. So, standard deviation is equal to 16.67. Now, summary. We have read four methods of absolute measure of dispersion. First is the range. There is maximum minus minimum value. Second is the quartile deviation. Half into upper quartile minus lower quartile. Third is the mean deviation. Individual series. Mean deviation about, if we are finding mean deviation about mean, then we will apply sigma d upon n. Mean deviation about median, then sigma d upon n, where d is equal to x minus median and median, and where d is equal to, in case of mean, d is equal to x minus x mean. In discrete series, remember one thing, mean deviation about mean, we multiply numerator by frequency, rest of the formula remains the same, and in denominator, summation of f, that is capital N. In individual observation, we use number of observation. Next is the mean deviation about median, sigma f into mode of x minus median upon n. In continuous series, mean deviation about mean, summation of f, mode of m minus x mean upon capital N. Mean deviation about mean, sigma fd upon n, where m is the mid value. Similarly, MD about mean deviation about median is sigma f into mode of m minus median upon sigma f. Again, where m is the mid value, and ignoring the signs in only mean deviation, because in formula we have used absolute sign. In case of standard deviation, again individual series, there is another formula, under root sigma x minus x mean upon n whole square, where n is the number of observation. In discrete series, we use frequency. So, sigma is equal to under root sigma fd square upon n minus sigma fd upon n whole square. And in continuous series, mean method, standard deviation is equal to under root sigma f into x minus x mean whole square upon n. Or sigma is equal to c into under root sigma fd square upon n, where capital N is the sum of frequency, minus sigma ft upon n whole square, where capital N is the sum of frequency, and this is the step deviation method. Thank you.